All right, welcome back to our second episode on our series on implementing a Lisp with Claude Code and Swift. If you recall, in the previous episode, we had a bug, and I've fixed that. And you can see that here in Claude Code, it's done a couple. It's fixed it basically. It added some tests and whatever. And if we go to our REPL, and now you can see that if I type in those examples that we did before, we now get the errors that we're supposed to. So now let's move on to what is the purpose of this episode, is to add the def special form to be able to evaluate the def special form in our REPL. So, but first, before that, I want to iterate that I'm a newbie at using AI assisted coding, and that's why I'm doing this project, is to learn more about that. So I'm completely open to any comments on how to improve. But I'm not a newbie at programming. I've been doing this for 36 years, so I know how to do software development. I'm just a newbie at AI assisted coding. So with that said, let's start this. And so what I decided to do, I had originally created a prompt on my own, but then I decided to use the advice of my friend Cole Joplin, who's a lot more ahead of me on this, and use Claude Code. And I said, create me a prompt for Claude Code to tell it how to implement the def special form. And it did that. And I noticed a problem with it, and I said that when you evaluate the def special form, it should return a symbol. It had it returning the value. And so then it updated it, and it came up with this prompt, which is a lot more thorough than my original prompt. I thought my original prompt was verbose, but this is even more verbose. And I suppose that's a good thing. So let's go over what def does. Def is this. So normally when you evaluate a list, let's look at Clojure. Here's the Clojure interpreter. When you evaluate a list, it will look at the first element of the list, which in this case is the symbol f, and expect it to be a function. And here we haven't defined f, so it gives me an error. Or you can do a function literal, which I'm not going to show that right now. Or it can be a special form, which is kind of think of a special forms as like keywords, where when the evaluator sees a special form, it knows that it needs to perform some special evaluation. So def is one of those special forms, and that's how we define a variable. So you can see up above, you give def, you do the symbol def, and then you give it an identifier name, and you give it a value, which could be any expression. In this case, we'll stick to literal since that's all we have in our REPL. And now my ID will evaluate to 2. So that's kind of what we want to do. We're going to do the def part. I'm not sure if we're going to get to the evaluating of the ID yet. So we've got this prompt. I'm going to copy it and paste it into here. Oh, I can't see it. That's weird. I'm not sure how to deal with that. Well, we're in plan mode, so let's just go ahead and accept this and see what it comes with. So Claude's churning away. It's reading what it needs to do, reading my source files. planning. I'll probably fast forward this or cut it or something. This can take a few minutes, usually when you're planning. Now it's reading some key files, reading more source files. Oh, one thing I forgot to mention when you're doing def, that there's also an environment the evaluator keeps track of. So when the special form def is evaluated, it takes the value, and the environment is just basically a symbol table that keeps track of all the values of symbols. So def just adds an entry to the environment for the value for that symbol. All right, so Claude has a plan. Let's look through it and make sure that it sounds correct. So the value is currently a stub. Every expression self-evaluates. That's correct. To support def, we need an environment to store bindings. Symbol lookup in def as a special form. This also means a val must become throwing. Undefined symbols. Okay, that sounds good. So it's going to add evaluator error for undefined symbol, invalid def. Description, that might mean that really should maybe be a syntax error that the parser detects. It's going to add an environment class that maps a string to an expr. A string is our symbol. So it's got that symbol case, undefined symbol. This case, check if first element is a symbol def, handles it, validate that it has exactly 3 elements. Second element must be a symbol, validate the third store, return the symbol. Otherwise, we're just going to return the list, even though that's not how normally Lisp, but that's where we are at the moment. So let's see, this is looking good. Now we have to have tries for the evaluator. Symbol lookup. Okay, that looks good. And now it says, should we go ahead? And I'm going to actually modify it and say, instead of the evaluator throwing invalid def, let's have the parser detect the invalid def and return a syntax error. I'm not sure that this is the right thing to do, but I know that we should return a syntax error. If we look at Clojure, you'll see that I did that before, right here, and it returns a syntax error. 2 Marty arguments def. So I want to have the same kind of functionality, so I'm going to tell it to do that, and now it's going to go and think some more. It agrees with me apparently. Reading some more files. Now it's going to update the plan. All right, let's revalidate the plan here. we have the context, everything is pretty much before, except we have the parser is handling the invalid def. And then we have the evaluator, the environment. Everything is going to update some tests. Parser tests now. I think we are good, so let's go ahead and accept the edit and have it write this code. And you can see here in the corner of I have the Xcode project, and you can see that when it modifies the files. All right, cooking, as it says, as the kids like to say now. It's going to implement the changes. Shows you as it does them. We see that it's modified the parser. Now it's going to update the evaluator. And the parser, and it's updated the interpreter Swish class in Swish kit. Still, now it's writing the tests, the evaluator tests. And now it's going to do the parser tests. Okay, it's got some, now it's going to run the tests, make sure they pass. All right, it thinks it's done. It's all the tests have passed. There's a summary of what it did. Added some parser errors, added validation parse list, updated the evaluator, added an environment, added an evaluator to the Swish kit, and added a bunch of tests. I like to go validate this myself, so I'm gonna run the test myself. Whoops. And they all pass, and I'm gonna run the project myself. So let's see what happens. Let's type in invalid def. There. Let's do more. We get another error. All right, let's make XP5. It returns the symbol. Did it add a value? It already added evaluation for me, so that's cool. Can we redefine it? We can. So X is 6 now. All right, looks like it's working. Can we define Y to some other value? We can. What if we do another list? It does that too. All right, it's looking pretty good. Let's go look at the changes it made. I like to verify the changes it made before I check things in. So let's start with the parser. And okay, it added the invalid def parser error. And it added the validation of the def. Let's look at the parser tests to go along with that. Let's see if we can find them there. Okay, here we go. Now it's got some def. That should be valid. All right, so it's got all these tests for the different cases of the def. Let's look at Swish kit. It added an evaluator, and it catches any errors, throws any errors. And finally, let's look at the evaluator. It created an evaluator errors, and it created an environment right in there. Normally I would like to break that out in a separate file, but it chose to do that. And now we have the evaluator, and if we look, all these symbols evaluate to themselves. For a symbol, it looks it up in the environment, and if it's a list, we look if we have the def special form, in which case we're going to define it in the environment. And everything looks good. So I'm going to mark the def as good, and I'm going to tell Claude Code to commit this. All right, it's committed it. As a reminder, I have put this up on the repo, so I'll push that code that we just did, and it'll be up in the repo, so you can check out the code yourself. But yeah, so that was a lot quicker than I thought. Very easy, so it's kind of amazing how productive you can be with these tools. Thanks for tuning in. The next episode, we will I'm going to do some refactoring to create a reader. Right now we have a lexer and a parser that should really be encapsulated into a reader. That's normally how Lisp do it, and that's what I'm going to do next. So see you next time.